of the triangle OBE. Okay, so let's do that. We've got all these values. Okay, so this must be equal to the area of the triangle OAC is a half x1 y1. Okay, plus the area of the square. Okay, the square CDBE is x2 minus x1 y2. Okay, plus the area of the triangle ADB, okay, is a half x2 minus x1 times y1 minus y2. Okay? And we to take away then minus the area of this triangle OBE, which we calculated to be minus, so it's minus a half times x2 y2. Okay? So all we have here now is we can just apply some let's say algebraic manipulations here. Okay, let's just multiply out the brackets. Okay, so let's see what we have here. So we have I'm gonna do this let's say a little bit of a, let's say maybe a bit of a convoluted way. Yeah. Okay. See, I can sort of see that I have x2 minus x1 here, and I've got one of them here. Okay, and but here I've got an x2 minus x1 times a y2. So that factor times minus y2 would be minus it, and actually times a half would be minus a half of them. So let me just write that down here. Yeah. So actually, I'm just going to expand out this here. So this becomes a half of x1 y1 plus x2 minus x1 y2. Haven't done anything here. Okay. And then it's this factor here times y1. So it's plus a half of x2 minus x1 times y1, and it's this factor times minus y2, so it's minus a half of x2 minus x1 times y2. Okay, that's now we've actually expanded this out. Okay, minus this half here, the half of x2 y2. Okay. So you see actually what we end up with here is that we end up with, there's a half of these and there's a whole of these. So when I take this away from this, I end up with a half of that. So this now becomes a half of x1 y1 plus a half of x2 minus x1 y2. Okay, plus a half of x2 minus x1 y1. Okay, so I added these two things here together to give me this, and then I'm adding this. Okay, and then I need to take away a half of x2 y2. Okay, so now we can multiply out the brackets. Okay, so now we have this is equal to a half of x1 y1 plus a half of x2 y2. Okay, minus a half, okay, of x1 y2, okay, plus a half of x2 times y1, so plus a half of x2 times y1 minus a half of x1 times y1 minus a half of x1 times y1, and finally minus the half of x2 y2. So let's see what we have. Okay, we have a number of like terms here with different signs, I suppose. So we can see that we have an x1 y1 here. Okay, a half x1 y1. Okay, which is going to cancel with this minus a half x1 y1. And we have a positive half of x2 y2 here, and we have a negative one there. So them two things cancel out here. So what we're left with now is two terms. Let's do the positive one. Let's do the positive one first. Okay, so this is equal to a half of x2 y1 minus a half of x1 y2, which gives us it's a half of x2 y1 minus x1 y2. Okay, and let's just keep in mind that areas are always positive, so what we do is this is a half of the absolute value of x2 y1 minus x1 y2. Okay, which is our formula. Okay, so what we're really saying here is this, is that given a triangle OAB, where one of the vertices is the origin and the other two vertices are x1 y1 and x2 y2, that the area of this triangle, and it doesn't necessarily have to be a right angle triangle, it can be any triangle now, okay, is given to be equal to a half of the absolute value of x2 times y1 minus x1 times y2. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you. And thank you for watching. Okay, bye bye.